Thank you very much. So, thanks for coming again. So, today is a little bit more sort of, it's kind of like a personal view on doing large-scale clinical trials. I started off doing large-scale trials about 25 years ago. I just sort of looked around and I said, look, who's doing good research? And it was the cardiologists. In cardiology, we had safe, effective treatments. And I thought, well, why do we have such good treatments for heart disease? And it's because I concluded it's because they do big trials. They do very large randomized controlled trials and they get very clear-cut answers. And so the how to do big trials became something very important to me. Now, a lot of people think trials go like something like this. You start off with an investigator, usually a man, very senior, austere investigator, and they have a great idea. They want to build a trial, and so they have a protocol, which is a plan of how to do it. And then everybody realizes that you need a sample size, you need to know how many bricks you need to do this big thing, and so they do their sample size estimate. And out of that, this beautiful structure of knowledge emerges. But it's not like that at all. Between the protocol and the result, oh, that slide didn't want to show yesterday either. Something about that slide. And the result, oh, this slide doesn't want to show either. Okay, but it doesn't matter. Between the protocol and the result are two slides you can't see, and this. This is the recruitment. Isn't that mysterious? I wonder why those two slides refuse to be shown. I'm glad this one, you can see this one because this is what I wanted to show you. This is the hard bit of a clinical trial. Thinking of the protocol is easy, analyzing the results is easy, and the bit in the middle is the hard bit. Yeah? So so the first, like yesterday I was talking about this big randomized trial in head injury, like saying, okay, I think we should randomize 13,000 patients to get tranexamic acid or placebo to see if it stops bleeding. It's very easy to do that. I think anybody can do that. And then when you've got the data set, you divide it by the treatment and you work out the proportion of patients who died in this group and the proportion of patients died in that group. That's very easy too. The difficult bit of randomized controlled trials is the recruitment. And that's what you have to get good at if you want to do them. And this process is the doing of science. And the doing of science is science, as far as I can tell. When somebody's in a laboratory doing experiments with genes or gene editing or something, we call them a scientist. But when we do experiments with people, I don't know, they call them managers or something, people who do this, but this bit is the hard bit of clinical trials. And I think it's something, you can't see it in the textbooks. They don't write textbooks about how to do randomized trials. They tell you about how to do a protocol and how to analyze the results, how to interpret other people's randomized trials, but they don't tell you actually how to do randomized trials. And I think it's a skill that's passed. It's more like a skill. It's more like a craft. And craft, you learn from watching somebody else who's done it. So, this is like a stonemason, crafting stone into beautiful shapes. you can't tell somebody how to do that. You know, you can't really, you have to learn from somebody, you have to watch somebody else do it. And so we did that. We started watching other people and learn from experience, learn by doing, and it's all about process. It's all about the doing and not the outcome. That's one of the things that I've learned. So the first big randomized trial that we did, I was very interested in head injury. And head injury, you know, huge problem worldwide. And about 20 years ago, like half of the world's doctors would give this patient steroids. And half the world's doctors would not give steroids. And the world was divided. Neurosurgeons thought steroids were either life-saving or lethal. And one group was right and one group was wrong. And so we had to find out who was right and who was wrong. And so I thought, well, okay, it's an obvious solution, so let's do a randomized trial. Let's do a big randomized trial. Let's randomize 20,000 patients to get 10,000 get steroids, 10,000 don't, and see who does the best. And I got a grant from the Medical Research Council to do this. I applied. I'd never done a big trial before, but I got a grant from the Medical Research Council to do a big randomized controlled trial called the CRASH of steroids in head injury. And this slide, it's about burnout. I don't know why it's doing that. Let's have a look. Okay, it maybe doesn't like this, but you can tell this is a very sickly slide. Oh, I don't know if it is about that. Do you think so? I don't think so. I think it's probably something about the colors or something. But you can see that this is the recruitment curve, and this is the burnout point, right? So I got completely exhausted trying to randomize 20,000 patients with head injuries.